So I'm Chase Faring, a student at the University of Wisconsin-Platteville, and this semester in Dr. Beebe's analog electronics class, I built a variable voltage supply for my final project. So I'm going to go through some of the theory behind the variable voltage, building a variable voltage supply. So from the wall, you get your 120 sinusoidal wave. This is RMS, by the way. And to get that down to a voltage that's usable in our circuit, we use a transformer. The transformer I used has a 120 to 20 turns ratio. So after the transformation, you have a 20 RMS peak. And we don't want this negative part here in our circuit, so we use a diode bridge, which effectively cuts off this bottom half and moves it to the top, so we just have the magnitude of the sinusoidal wave. So that's down here, as you can see. And while that looks pretty cool, it's not all that useful. So to even this out, we use some capacitors which store energy. And so on the first cycle here, when you power up, your capacitor is going to charge with the first cycle of the wave. Now as this wave goes negative, your capacitor is not going to want to discharge immediately. So during this cycle, your capacitor will discharge a little, but it won't dip too much. So basically what you have is a ripple which rides these rectified waves. And the difference between the peak and the bottom is very small, so it can be used as a DC reference. So after the rectification and ripple, we come down here to a voltage regulation chip. I use the LM317. So the voltage comes in here, and the chip provides a constant 1.2 drop across this R1 resistor. R1's typically picked to be constant, so I chose 200 ohms. Your R2 down here is a potentiometer, and the output of this chip is shown through this relationship here. So the V reference is your 1.2 volt, and you adjust the output by changing R2 on the top here. And connected to the output of the chip is a BJT power amplifier. So your output current comes to the base of the BJT. It's biased with the input DC voltage. And what this does is it gives you a current gain determined by the beta of the transistor. So we're going to go over to the actual circuit now. So right here you have your power coming in. This is a toroidal transformer. It would step down the voltage. That comes to a rectifier bridge here, which goes through a resistor for current limiting. These are the capacitors I mentioned that create the ripple voltage. Then this is a voltage regulator chip, which provides a constant 12 volts, which powers the fan over here. The fan is used for cooling the circuit because these components get really hot with the load connected. And I'm going to go ahead and fire this up. So as you can see, our fan comes on. If you come out front here on the front panel, you can see our banana header pins, which you can connect your banana cables up to. We have an analog voltage meter here, and to show you guys that this thing actually works, we created a little gizmo here. It's a DC motor with some LEDs on it. So we're gonna go ahead and fire this thing up and show you that it works. So as you can see, we got about a 5 volt output here. And with the regulation of the chip, you can see when I disconnect this load, you're not going to see a lot of fluctuation in the output. So that's some of the theory behind variable voltage supply construction.